Okay, good morning. As I just mentioned, the take-home quiz is going to postpone till next week for those who are not here. Today, we're going to continue with Chapter 6, more uses of interrupts, mainly using the timer zero overflow interrupt. So we're going to talk about periodic interrupts more, event counter, how to use timer zero, change the clock and use it to count events, and measuring time between events. Okay, then I'll go to the sleep and mode and watchdog timer. So last time we did an example on using hardware generated delays versus previously we did loop-based delays. So if you remember the code we wrote last time, I actually uploaded two demos to the class demos on the learning management system. Where is demos? Class demos. Okay, I uploaded two demos, actually 7 and 8. 7 we wrote it entirely from scratch here in class. 8 and we started with it, and I told you that I'll upload the executable here, but we converted the type of delay here into a function that we were able to pass the amount of delay we want, and it looked like this. I think this is it. We wrote a function called my millisecond delay. It is based on timer zero overflow interrupt. And here I can pass 500 milliseconds, 5,000 milliseconds for 5 seconds, any whatever amount of time in terms of millisecond. And the delay function we wrote is this one. So it takes an unsigned integer. So the maximum number I can pass here is 6,536, which is around 6.5 seconds. Okay, and what we did is that we the timer zero overflow interrupt here. Okay, we set the clock and prescaler here, and we that after setting the clock and prescaler, that every increment will take 128 microseconds. So we need to count from 247 instead of 0 to overflow. And that was like, I forgot, 247 to 255 is like 8 times, right? 8 times to get 1,000 microsecond, which is 1 millisecond. So we made the timer overflow every 1 millisecond, and then in the overflow interrupt, waited here, we got stuck here until a delay counter that increments every 1 millisecond inside the interrupt service routine. Then we disable the interrupt again. Inside the interrupt service routine here, not the external interrupt, the timer zero interrupt, this one. Every time we get in, we set timer zero value to 247, because when it overflows 255, it goes back to 0, right? We don't want it to come from 0 to 255 again. That's more delay than 1 millisecond. So we set it 247 to continue counting from 247. And we increment a counter here that we wait for in the delay function. That's what we did last time. Today, and this is a periodic interrupt. Anyways, you come here, you come here every 1 millisecond, right? And increment a counter. This is periodic. However, we still relied on the main loop here, the infinite loop inside the main function to do our core business, which is shifting the LEDs, if you remember. And we're wasting a lot of time. We're using delay here. And the delay function, even if it's hardware-based delay and it's precise, but still here we're waiting here. And this instruction is gonna get stuck for the amount of delay you ask for, right? So you're keeping the CPU busy waiting for this counter to become equal to the value you asked for, the delay in terms of milliseconds. So we're still yet wasting the time of the CPU. We can do better, okay? What can we do? Instead of having all this in the main loop, instead of having all this in the main loop, we can have it in the interrupt service routine. So every 500 milliseconds here, in the here, we just do the shift and empty the main loop, Let's do a quick example on that. But I want to build on something we have. If I go to the demo, let's build on this one, copy and paste it. Okay, and call it demo 9. And call it periodic delay. Periodic interrupt, sorry. Periodic interrupt empty. Okay, so let's do this. Modify this. This is the code we wrote for the shifting LEDs every 500 milliseconds, okay? But this is the one that was not using the delay. This is the one that was using the interrupt. We raised the flag every 500 milliseconds, and we kept waiting for this flag to raise. When it's raised, we clear it again and do the shift, okay? What I want to do now is this. We're already getting into this interrupt. This is the interrupt service routine, the external interrupt service routine, then the periodic interrupt service routine. We know that we get into this, if you remember, this timer overflows every 32.7 milliseconds. So we increment a delay counter every time, times 32, times 15, 32 milliseconds times 15 is about 500 milliseconds. So this if condition, what's inside it, is going to execute every 500 milliseconds. So we can put the delay, the shift here. We could put the shift here and remove it from the main loop. So what I'm going to do, I'm going to go to this while loop, this one, and delete everything in it. هاي الوايل لوب شايفينها. So بس عشان let me just keep track of the so this is for the first 4. This is the second 4. هاي للوايل وهاي للمين. Delete. See, I'm gonna keep my program without any while. This is all ideal time. I'm gonna just go every 500 milliseconds, go to the interrupt service routine, do the shift, and then go do nothing. Ideal time. See, when you go check your CPU like this, and see, sorry, where's the place where you see the CPU performance? CPU, see, when the CPU is ideal, not doing anything. It is doing anything, but it's doing it right. It's not wasting its time just doing something that you can go check every amount of time and do it. So what we're gonna do is to just do a simple modification on this program. And the modification is to do the shift inside inside the interrupt service routine here. So we know that we are going to get into here every 500 milliseconds here. Tamam? So what I want to do, but before we had the for loop for I equals 1 to 7 to shift, right? Now I'm going to do something like a shift counter because I want to keep track. So I'm going to define a shift counter that counts how many times we shift, okay? So I'm going to go define a shift counter here, and it's not going to supposed to count more than 15 times. So a character, unsigned character will do it. So let me call it shift counter. And initially it is 0. Initially it is 0. Okay. And every time we go into this if condition, which happens every 500 milliseconds, I increment the shift counter, okay, plus, and check it. If it is less than 8, let me just copy it so not to keep writing it. If it is less than 8, yani 7 times, right? Shift port C equals port C shifted left 1 time, right? And we said we can replace the shift operator with a multiplication by 2, right? Because the shift left is a multiplication by 2, right? Else, if the shift counter is greater than 7, and we did the 7 times, shift it right for port C. Shift right, 1 location. And then after finishing the first 7 shifts and the second 7 shifts, well, remember, every 500 milliseconds, either this is going to happen or this is going to happen, or not both, right? For 1 time. Then every time check if my shift counter equaled 14, 7 right, 7 lefts. If it's equal to 14, then just clear it again to start over, right? And this delay counter that we rely on to know that we have the 500 milliseconds elapsed, we need to clear it again, because it became 500, right? So every time you get into here, the delay counter, you clear it. We already did. Now the flag, we don't need this flag anymore, right? We used to use it in the main loop, so we can remove it. Tamam. And then we clear the flag of the overflow flag. What did I remove right now? There is a delay flag. I'm gonna just remove this delay flag. So we have a delay counter, a shift counter. Khalas. What happened? Okay. Let me just look at the main loop. If anything, does it look right? Nothing. Everything okay. Now this delay, we can delete it, right? How the delay? We're not using it anymore, so we can delete it. See? So what do we have? All our code is in the interrupt service routine, and we have an empty control main infinite loop. What does this mean? It means you have a lot more time to do things. تخيل يعني هذا البرنامج that made the CPU 100% busy, now it is making it busy for this amount of time, which could take مثلا, I don't know, 1 millisecond. You can do the math, right? Look at the assembly when it executes. 1 millisecond, 2 milliseconds, 10 milliseconds. every 500 milliseconds you are busy for 10 milliseconds, then you're not doing anything. يعني صح 10 يعني 10 من 500, right? Yeah, let's say 50 milliseconds. You out of 500, you're 90% of the time free. You can add much more tasks here, critical tasks, or anything else to do. Let's build this program and execute it. My delay. هذا my delay. We did delete the my delay. How about we do it again? This my delay, I don't want to use it. خلاص, because we deleted it. Now I want to blink this loop, the port B, whenever a button, an external interrupt happens, right? 10 times. Well, I want to toggle it 10 times, which means 5 times on, 5 times off. And if I want to blink it to see it 5 times, then we need to do it 20 toggles, right? طيب, how do we do this inside the periodic interrupt? Well, easy. We can do this. We can do this. We can just do, whenever an external interrupt happens, we set something. Let's go set something called maybe blink timer, or external interrupt counter, whatever. Let's call it, and it needs to count to 20. And so an integer unsigned, character would do it. Let's call it blink counter. And initially it is 0. Tamam. So whenever an external interrupt happens, let me delete this. Let me delete this. Whenever an external interrupt happens, the blink counter is set to 10, to 20. We want it 20 times, right? To 20. Blink counter is set to 20. Now we want to do it every 500 milliseconds. Okay, add it here, because you're in here every 500 milliseconds. If you want it every 1 second, you can do another if delay counter and have another delay counter that counts. If 1 second, make it count to 30, right? Yeah, so we can do this. We check for this if, yani, the first thing we do, if the counter is not 0 yet, just blink, right? Because we want to do it 20 times. So we can do it here. We check for this if blink counter, if this blink counter is true, not 0 yet. What do we want to do? 2 things. First, I want to toggle port B. Port B equals not port B. Then decrement the counter 1 time, right? So every 500 milliseconds, it will blink and check. Do I need to blink again next time? If it's not 0 yet, yes, I'm going to do it, right? Next time the interrupt happens, the external interrupt happens, this will go back to 20. If the external does not happen, this will decrement and become a 0. It will become a 0, right? Every time we blink.
ممكن
yes.
سؤال بس.
Yes, تفضل.
مش حكينا an interrupt can't interrupt an interrupt. يعني
yeah, true. But we're inside the same interrupt.
طيب اللي بنسويه
we are inside the same interrupt.
Okay.
صح? We're not getting out. We are هذا هو نفس الانتربت, right? We're inside it, doing a shift and doing a blink.
Yes.
هلا if an external interrupt happens, يعني a falling edge happens, to set this one, this is not going to be responded to if we are inside here. But how long are we inside here? a few milliseconds. Most of the time, we're here doing nothing. Got it?
Yes, yes. Thank you.
Yeah. Cool. So let's build the program. Program it. Done? Done, right? Let me just go share that camera with you guys. Okay, how do I do it? This escape. Oh. How do I do it? Escape. Stop sharing. How do I stop sharing? I lost the bar. Yeah, again. I stop sharing. Go move to the other camera so you can see the board. See the board? See the board? I'm going to reset.
دكتور مبين.
The LEDs are shifting every. Okay, we got lost here. See? We have a bug. It looks like it shifted here one more time. But what if we press the port B0? The blink is going to happen 10 times. Okay, let's go debug our code. The shift is happening more than it should have. Why? It's shifting left. When it got here, it should go back, but it kept going. Let's go just debug the code. Let me share the screen again. So if our shift counter, it started with 0, right? Shift counter started with 0. Every time here, we decrement it.
يا دكتور
We increment it, sorry. Yes, yes.
لا مش هنا في جوا الاف شيفت كاونتر لازم تساوي 14 ولا انا مش صح؟
Yeah, thank you, because it's we're assigning it, not it should be a logical comparison. Thank you. This is the numbers are right. Thank you. مين كان هذا؟
أحمد.
Ahmed, thank you, Ahmed. That was very helpful. We could have wasted I don't know how much time to fix it. Okay, I'm building. You're seeing the camera. I'm building. Programming. You guys see the board now? Finished programming. You see the board, or what do you see?
دكتور البورد اللي
It's working now. شايفين? Thank you, Ahmed. You saved our life. See, we did not reset. The problem we had, the shift counter, we did not reset. We assigned the shift counter a 14 every time. Then so it stopped the first if conditions. See, the shifting is very accurate, 500 millisecond. Whenever we do an external interrupt, وبعدين شوف, we did not stop shifting. Like multitasking, huh? Multitasking. If anytime you do an external interrupt, you blink and the shift keeps going. Because the CPU has a lot of time to do many things. And if you have anything in the while loop, you can do it. Beautiful, huh? Okay, let me go back to I need to, where's the control panel? Here. I don't see any excitement. Looks like any old boring stuff, huh? طيب ماشي.
لا دكتور.
Okay. طيب. So I'm not gonna do any more things here. خلاص, okay. You see how you can do a beautiful periodic interrupt, and keep your loop empty. Well, if you can do everything there and keep the loop for other stuff, that would be moving things and making the most out of your CPU is the good thing. Event counter. Another application of timer 0 is the event counter. Well, here's some math about hardware delays. We did the math, right, last time? We did some math to compute how to make the counter overflow every 32 milliseconds or every 1 millisecond, right? Remember, so this is just something I put in the slides, but we did it on the board last time. Another example. Okay, we did live demos. See how you can use the timer 0 as an event counter? We saw that timer 0 increments on a clock, and this clock can come either from the oscillator clock, instruction clock, oscillator over 4, or directly from outside, from something, a clock source tied to port A4. And this can be taken as is or prescaled. Imagine what this can do. This can cause timer 0 to increment without writing any piece of code to watch for anything. This could be tied to a door. It could be tied to anything. Because it's not going to take a lot of time, I'm going to do a real quick example here. A real quick example, like four lines of code. Because we have like 7 minutes, I'll finish this. Like 7 lines of code. See how helpful this could be. Hide the floating. So I'm going to close this project. Close project, and start a new project. And let's call it demo 9 or what? Browse. Let's call it demo 10. Let's create a folder here and call it class demo 10 event counter. And we're learning while writing code, right? Are we?
Yes.
Cool. Okay. So what do we want to do? I want to use this feature, this pin, port A4, falling edge or rising edge, we decided on it, to make, without a prescaler, to make timer 0 increment every time an event happens, without checking if then increment, well, okay? So we can do something like this. Inside our main loop, we need to set the option register to make it increment, to make the clock source be the external. We want to make the clock source to be this one. Okay, so what do? We go to the option register here. We don't want a prescaler. So the prescaler needs to be the prescaler, the PCA bit will be assigned to the watchdog timer. Okay, so the PSA here, this would be 1. So here and the watchdog timer, we don't do scale it, so 3 zeros, right? To keep it as 1 to 1, not affect anything. And then we want the increment to happen on a falling edge when we push the button or the signal on port A4, right? So timer 0 select edge, this one, طيب قبل select edge timer 0 clock select we want it to be a 1 to take it externally. Timer 0 clock select will be a 1. بعدين this one, do we want to take this as is? Yani on a falling edge or a rising edge? Okay, select edge. 0 will keep it as is, right? We don't want to flip it. So select edge would be a 0. Select edge would be a 0. And external interrupt edge, well, keep it a 0. Port B can be a 1 because we don't want to enable the pull-up resistor, right? The clock select is 1, right? Yeah. So this would be 0x. This is an A, right? 8. A8. So we go to our code and say, what is this? Save. Option register equals 0x A8, right? Select the external clock on a shared. It's not shared with port A4. Was it A4 or A0?
A8.
A4, right? No, I mean the pin number, A4 here. Tamam. Then that's it. We're done. We're done. All what we want to do now, first, to see what's happening, I need to display it on some LEDs or a display. So I'm going to use port C. So I'll make port C as an output, TRISC. This is just to visualize it, okay? This is not really needed, okay? And we want the timer 0 to start counting from 0, okay? And then in the infinite loop, all what we want to do is just visualize the value of port C on time of timer 0 on port C. That's it. Understand the code? We picked an external clock, then to increment timer 0, then we want to show timer 0 on port C. The 8 bits here reflected here, so we can see the increment for our own confidence. So I'm going to build the program. Building. Meanwhile, okay, done programming. Let me stop sharing, switch the camera.
دكتور هلا الاكسترنال كلوك من وين عم بيجي؟
Now, okay, from port A4. So you can get a function generator. You can get a function generator. And I'm going to shift this عشان you see port A. هيك شوي. You see it. طيب, if I have an external generator, I can go to the pin here. Do you see port A4 here? Here. See the screwdriver here? And tie any source, signal source that falls from high to low or low to high. Or if we're using the port, we can tie it here to any pin. Here's port A. But we know that the board is already set that every pin is tied to a push button. So this push button, port A4, let's make it, put a pull-up resistor on it. This is A3, sorry. This is A3. This is A3. So A4. A4 now is high. Every time I'm going to push the button, it's going to go low. And watch for port C. Now, when I raise this to high, the timer incremented, but I'm going to push the button now. 1. See? What is this? 2. Yani 0, 1, 0, 0, 0. Push it again. Oh, 3. شوف فيش debouncing. It went to 3 then 4. I'm going to start over. Reset. Okay? So I'm going to do it real quick. يعني to overcome this debouncing or is for a lot of time, so the CPU can sense this bouncing thing. So push 1, 2, 3. So I need to do it real quick. 4, 5. This is 5. 1, 0, 1. Right. 6, 7, 8. Yani and we should find, if you have a better signal. A, B, C, what is this? D. I did it longer. IF. Looks like every time I push the button, it takes 2. Yani, because I'm not doing really quick. Hi, بعدين. See that? Anyways, I'm pushing continuously, and this is a binary 8-bit counter that keeps incrementing every time a falling edge comes. See, we're incrementing the timer. We're just visualizing. Adding a delay, well, adding a delay will not help because this is a hardware edge, okay? All what we did is just select an external source for the timer 0. ماشي? This is another application. Last application is this. You want to do it next time or this time? One of the questions in the quiz was about something about thing like this.
دكتور لو للمحاضرة الجاية عشان نطلع على
Okay. And
المحاضرات.
classes? You have other classes? Okay, you have other classes. طيب, I'll end this class and we'll finish it next time. And next time we'll finish this chapter, by the way.
دكتور
So let me just stop the recording. Thank you very much. See you Sunday.